In this container I have the components for another kit by JYE Tech. This is the FG085 Arbitrary Function Generator. This is the version that comes with power supply and the proper faceplate as well as a back panel. Circuit board is down here, and thankfully most of the components, especially the SMD components, are already soldered in place. The manual for this thing is not nearly as detailed as the one for the little oscilloscope that I built. Making good progress. I have most of the components on the back of the circuit board installed. There are 5 electrolytic capacitors. There is a micro USB jack. Well, that's quite difficult to install because it's so small. And then there are these 2 headers. There is also a power jack. The kit comes with one of these barrel type jacks for the power supply that it came with. I'm not going to need that in the application that I have planned for this. Instead, I'm going to go with the second option that's given on the circuit board. I just found myself one of these connectors on a junked circuit board, so I'm going to put that in. I also found myself a cable that fits into that jack. And there we have the power jack installed, and that completes the back of the circuit board. Continuing on the front of the circuit board, I have all the switches in place. The ones over here are momentary push buttons. They get a white cap. And then there is this switch that does lock down. This has the red cap already on it, so you can't get that confused. What you can get confused, as you can see on the one side, the switch have a single tab, and then on the other hand side there are 2. And the 2 tabs have to go into the direction of the power connector on the circuit board. If you get that wrong, the switches are not going to work properly. In an online review, I read that somebody had problems. The push buttons would not line up with the faceplate correctly. So my initial plan was, as you can see, I have the standoffs screwed onto the faceplate, and I was going to have this in place while soldering the switches onto the board. But it turns out that there is not a lot of play once you have these correctly in the circuit board. So probably the reviewer did something wrong. So I'm just going to put these on. I'm going to solder these in place as they are right now. As you can see, looking at the back of the circuit board, I now have all the switches soldered in. This turned out to be much more difficult than I had expected, just to get these switches to line up with the surface of the circuit board correctly. So I can understand why some people had difficulties with this, because obviously if the switches sit on the board at some sort of an angle, they're not going to line up with the faceplate anymore. I have already tried on the faceplate, and it does fit. As you can see, I also put on the rotary encoder, which was much easier. The next step is installing the display. What you're supposed to do, going by the manual, is to insert this strip into the circuit board, like so. Then just line up the display with that, and like so, and solder that in place. I don't like that because that leaves the lower side of the display just flapping about. It's not very solid. So what I'm going to do is I'm going to mount that properly. In order to do that, I already took this to the drill press and opened these holes in the circuit board up to 3 millimeters diameter. Originally, they were only 2 millimeters. The display already had 3 millimeter holes surrounding it, so I could just simply put some screws through it on the bottom, and I held them in place using one nut, as you can see. And the nut has the same width, roundabout, as the plastic on this contact strip. And here we have the display mounted to the main board. We have the two screws down there, and then up on top is the contact strip, which still needs to be soldered in, obviously. Almost a bit surprising, all the solder joints on top of the main board do clear the display. There are no conflicts. And on the bottom, there are the two nuts holding the display in place. Now, this one over here, it does seem to clear the traces on the board surrounding it, but you don't want to tighten this down all too much. The display has been soldered in, and that almost completes the function generator. Now, this is the point where I'm going to stop following the instruction manual, because now this thing joins the game. And yes, I know this is way too big, but it's the only one that they had in the store with a front big enough to fit the front of the function generator. That took some careful measuring. As you can see, I got the 4 mounting holes in the front as well as a cutout that does clear all the buttons of the frequency generator. So I should now be able to put this together with the faceplate. Here is a first test fit, and this is where I ran into some problems. Something that I did not take into consideration is the thickness of the metal. And what happens, you might be able to see that already, what happens is the knobs are not sticking out far enough so that you can push them properly. Bought this thing at a flea market for €16, and it turned out to be really helpful to shorten down these standoffs. I took away about 2 millimeters of each standoff. Obviously, holding them straight onto the rotating machine would be a very dangerous thing to do, so I found this much longer standoff, and I screwed the short pieces into it, and using this, I was able to safely hold those standoffs. Following the 4 steps in the instruction manual, I now have the BNC jack mounted to the front. I have used 2 washers to hold it in place. And there we have the assembled function generator. Now, unfortunately, I just had the first major failure. It doesn't concern this module, luckily. To power this up for the first test, I was going to use the adapter that came with it. Well, I plugged the thing in, turned on the power strip, and I got a huge spark, and the breaker in the fuse panel outside tripped. If you plug it in now, there is no more spark, but there is also no output from this AC adapter. So I'd say this thing is junk. Here is the inside of the AC adapter. All the components appear to be fine. The problem is the circuit board itself. This is unsafe. With the help of a better power supply, let's now test this function generator. Let me press the power switch, see what happens. Oh! Oh, that looks promising. Let's hook this up to the scope. I spent the past half hour testing this in all sorts of different ways, different waveforms, frequencies, amplitudes, offset levels, and it all seems to be working fine. At first I was having some problems. I just couldn't get a clean signal out of this, but it turned out that was the fault of the BNC cable. It seems to have a slightly dodgy connection up there. So, as shown on the scope, we have a frequency of 100 kilohertz, and about 5 volts peak to peak. And that's exactly what we've set on this unit. This is not the cleanest signal I've ever seen, but for what it is, it's pretty good. It's certainly better than my old XR2206 based analog frequency generator, which is good because this is supposed to be the replacement for that. So, thank you for watching the first part of this video, and the second part is hopefully going to follow soon.